So in the next case, the leading coefficient is positive, and the degree n is odd. So, 3, 5, 7, 9, right? Those are odd degrees. And so when that happens, the end behavior of the polynomial function is similar to that of the cubing function. The right end goes up, the left end goes down. Okay. So over here, adding words, in this case over here, right, we could write both ends rise. In this case here, you could write both ends fall. And then in this case here, left end falls, right end rises. Okay? And then the last case is where the leading coefficient is negative and the degree n is odd. So when that happens, it's the opposite. The left end goes up, the right end goes down. So in this case, you can write left end rises, right end falls. So that's important information in graphing a polynomial function, right? Getting a rough sketch of a polynomial function. Knowing the end behavior. Does the graph go up or does it go down on each end? Okay. All right. So let's take a look at page 2. And you might draw this graph at the top of your page. It talks about turning points. So here is an arbitrary graph of a polynomial, right? I'm just making this up. Don't ask me where I got it, okay? And graphs of polynomial functions are smooth curves, okay? They're like, you read a graph from left to right, right? I like to read a graph as hills and valleys, okay? So here we're going up the hill, then we're going down the hill, then we're going up the hill, then we're going down the hill, so forth, okay? Where you're at the top of the hill here, or bottom of the hill here, top of the hill here, those are called turning points. That's what the definition at the top of page 2 is talking about. Okay. In calculus, these are called relative extrema. Okay. Relative maximums, relative minimums. Right, but in algebra, right, we just refer to them as turning points. You're going from uphill to downhill, downhill to uphill. Yes, ma'am.
Is there a difference between a turning point and an inflection point?
Yes,
Okay.
absolutely. Yeah, absolutely. Okay. And you'll talk about that in Calc 1. Okay. Yep. All right, so let's take a look at example 2. It says use the zeros and the end behavior of the polynomial function to sketch an approximation to the graph of the function. Okay. So in example 2, where it's talking about the zeros of the polynomial function, okay, those are the x-intercepts. In the graph of the polynomial function. Is is where the y coordinate or the value of the function is equal to 0. Okay, you know at an x-intercept, the y coordinate is 0, which means the function is equal to 0 at an x-intercept. Okay? So you know with x-intercepts, the graph crosses or touches the x-axis. Okay? And where f of x is equal to 0, right? The y coordinate is also equal to 0, right? Because function values and y values are the same thing. Okay. So we're going to use the x-intercepts, or the zeros, and the behavior of the polynomial function to sketch an approximation to the graph of the function. So in A, we have f of x is equal to minus x cubed plus 4x. So what's the leading term in this polynomial function? Minus x cubed. What's the degree of this polynomial function? That's odd, right? What's the leading coefficient? This minus is negative. Out here is a minus 1, right? Minus 1 is the leading coefficient. Okay. So do we know what the end behavior in the graph of this polynomial function is? Certainly do. The end behavior mimics minus x cubed. It's going to go up on the left end, go down on the right end. Now I may have to erase that, right, in drawing my graph, and, but this is an important piece of information that we know on each end whether the graph goes up or whether it goes down. Okay. Now, what we got to find are the x-intercepts in the graph of this function. So you replace f of x with 0, and then you got to solve for x, right? Well, on the right-hand side, we can factor out an x, right? So I'm going to do two things at once: replace f of x with 0, and then factor out an x. In fact, I'm going to factor out a minus x. So when I factor out minus x, right, I have minus x times x squared minus 4. Well, x squared minus 4 is the difference of squares. It factors into x plus 2 times x minus 2. So to get the x-intercepts, or the zeros, I set each of those factors equal to 0 and solve for x, right? And I get, when I set minus x equal to 0, I get x equals 0. When I set x plus 2 equal to 0, I get x is equal to negative 2. And when I set x minus 2 equal to 0, I get x equals 2. Okay? So these are the zeros or x-intercepts of f of x, of this polynomial function. Okay? All right. So we have a 0 or an x-intercept at -2, an x-intercept at 0, x equals 0, and x-intercept at 2. Okay. Now, we haven't talked about this. We're going to talk about this in a moment, but the exponent on each of these factors, right? The exponent on x is 1. The exponent on x plus 2, the factor x plus 2 is 1. The exponent of x minus 2 is also 1. And so the graph crosses the x-axis at each of these zeros. Okay. And we're going to be talking about multiplicity here in a second. But you just have to take it by faith, right? What I'm telling you is that the graph crosses at each of these zeros. So if it crosses at x equals -2 and it goes up on the left here, it must come down something like that, right? And then it's got to turn and cross at x equals 0. So there's got to be a turning point in here somewhere where the graph turns and then crosses the x-axis at x equals 0. And then there's got to be another turning point between 0 and 2 where the graph then comes down and crosses at x equals 2. And then it goes down forever on the right hand side. So this is a rough sketch. It's not an exact, but it's a rough sketch, okay, of the graph of this polynomial function. Okay. Goes up on the left end, goes down on the right end, and crosses the x-axis at -2, 0, and +2. Okay. Because those are the x-intercepts. Okay. Any questions on that? All right, so let's take a look at B. So B, we have f of x is equal to x to the 4th minus 5x squared plus 4. Okay. Now, this one's a bit more trickier. Okay. Do we know what the leading term is? It's x to the 4th, right? So what's the end behavior for this polynomial going to be? Both ends are going to go up, right? Like a parabola. That's right. That opens up. Okay. But now here's the tricky part. We got to find the zeros or the x-intercepts, right? So you got to replace f of x with 0. And then solve for x, right? Is this a quadratic function? Somebody say no, that's not a quadratic function because that's x to the 4th. Okay? But then we can factor this like we would a quadratic by doing a variable substitution. Okay? So notice we got x to the 4th and then x squared. So this is, we can transform this into a quadratic equation that we know how to factor. Let's let u equal x squared. Then if I square both sides, I have u squared is equal to x to the 4th. Okay? So all I did was square both sides. Now, so we're going to substitute u squared for x to the 4th and u for x squared. And when we do that, we have u squared minus 5 times u plus 4 is equal to 0. Now, is that a quadratic equation in the variable u? Do we know how to factor that? Yeah. So this factors into u minus 4 times u minus 1. And now you set the factors equal to 0, just like you would with the variable x. You have u minus 4 is equal to 0, u minus 1 is equal to 0. Remember, we're trying to find the x-intercepts for the graph of f of x here. Okay. Well, what's u equal to? X squared. So we replace u now with x squared. X squared minus 4 is equal to 0, and x squared minus 1 is equal to 0. So in this step, we did the substituting, right? U for u squared, and u squared for u to the 4th. And in this step, we factor. And then in this step, right, we set the factors equal to 0. And then this step, we replace u with x squared. So now we can find the x-intercepts, right? So here we have x squared minus 4 is equal to 0. Okay. So there's two approaches. You can either factor x squared minus 4, or you can do the square root method. You add 4 to both sides, you get x squared is equal to 4. And then you take the square root of both sides, and you get x is equal to plus or minus 2. So x equals minus 2 and x equals plus 2 are two x-intercepts of this polynomial function. Same is true here, right? You add 1 to both sides, get x squared is equal to 1. You take the square root of both sides, you get x is equal to plus or minus 1. So x equals minus 1 and x equals plus 1 are also x-intercepts in this graph of this polynomial function. Okay? And you can plug minus 1 and 1 and minus 2 and 2 in for x and verify that the function equals 0 for those values of x. Okay? So this polynomial function x to the 4th minus 5x squared plus 4 factors into x minus 2 times x plus 2 times x minus 1 times x plus 1. That might be more obvious if I had factored instead of using the square root method. Okay. X squared minus 4 factors into x plus 2 times x minus 2, and x squared minus 1 factors into x plus 1 times x minus 1. Okay. So the exponent on each of these factors is 1. And so the graph of this polynomial function is going to cross the x-axis at each of these x-intercepts. So let's get our crude approximation to the graph of this function. What's the y-intercept? Do you know what the y-intercept is for this polynomial function? What is it?
4.
Yeah, 4, right? Now to find the y-intercept, place fx with y and put in 0 in for x, and you get y equals 4, right? So it's going to cross the y-axis, right, up here at y equals 4. All right. The leading term we said was x to the 4th. Right, so the coefficient is positive, the degree is even. And so we know on the left end the graph is going to go up. And we know on the right end the graph is going to go up. And we know the graph is going to cross at each of those 4 intercepts. So here on the left end, the graph is going to go up from the far left x-intercept, -2. And as it crosses the x-axis, it's going to turn and then cross again at x equals -1. And it's going to go all the way up here to y equals 4, cross the y-axis there, and then turn, come down and cross the x-axis at x equals 1, and then turn and cross the x-axis at x equals 2, and then go up forever on the right hand. So there's a lot of deductive reasoning in graphing these polynomial functions, right? A lot of deductive reasoning. Okay? Now we're just getting graphs, that's all we're doing. Okay? So we graph the x-intercepts, the y-intercepts, and the end behavior. Yes, ma'am?
Is it true that, excuse me, one might, like, if you have, like, the highest degree, and then -1 from that is how many turns that graph?
That's the maximum
Okay.
number of turning points. That's not the exact number. That's the maximum possible. Okay. Yeah, it's a good point. Okay. And you can see we have 1, 2, 3 turning points. But you don't have to have exactly the degree -1. Okay, that's the maximum number. Okay. Because the polynomial function, say g of x equals x to the 4th, the degree is 4, right? But the graph is U-shaped, only has 1 turning point. So n-1 is 3 in this case, but it only has 1 turning point. So that's the maximum possible. Okay. All right. Any other questions? Okay, so let's take a look at example 3. Find a polynomial function with a leading coefficient equal to 2 and zeros -3, -1, 3, and 4. So remember, zeros and x-intercepts are the same thing, right? So it's an x-intercept or 0 at x equals -3, x equals -1, x equals 3, and x equals 4. Okay. Now, if x equals -3 is an x-intercept, then x plus 3 has to be a factor in the polynomial, right? So if I add 3 to both sides, right, I get x plus 3 is equal to 0. I add 1 to both sides, I get x plus 1 is equal to 0. I subtract 3 from both sides, get x minus 3 is equal to 0. I subtract 4 from both sides, I get x minus 4. Right? We're sort of working in reverse. Usually we factor the polynomial and then find the x-intercepts. Here we're finding the x-intercepts and now we're factoring the polynomial. Okay? So f of x, the polynomial, I'm going to leave a space out here in front, can be written as a product of these four factors. X plus 3 times x plus 1 times x minus 3 times x minus 4. So if you were given this polynomial function, you were asked to find the x-intercepts from the graph, you would set each of these factors equal to 0 and then solve for x to get the x-intercepts. All right, we're just going in reverse. Okay. But we're given one additional piece of information. Okay. We're given that this polynomial function has a leading coefficient equal to 2. So we got to multiply all this by 2 up front. So this is a factored polynomial that has a leading coefficient of 2, and the x-intercepts are at x equals minus 3, x equals minus 1, x equals plus 3, and x equals plus 4. You set all those factors equal to 0 and solve for x, you get the 4 x-intercepts, or the 4 zeros. Okay. Any questions? Deductive reasoning. Okay? That's all it is. Deductive reasoning. Okay. Any questions on that? So at the bottom it talks about multiplicity. Okay. If a polynomial f of x has a factor of the form x minus c to the k power, k is greater than 1, then x, when you set that equal to 0 and solve for x, right, you get x is equal to c, but we say x equals c is a repeated 0 of f of multiplicity k. Okay? Then knowing the multiplicities, whether they're even or odd, is important in graphing the polynomial function. If the multiplicity is even, then the graph flattens and just touches the x-axis. Okay? So if the multiplicity is even, here's the x-axis, then in the graph of the polynomial, it'll just touch and turn, right? Either way, okay? Either above the x-axis or below the x-axis. The graph will just touch and turn, okay? So this is if the multiplicity is even. Graph touches and turns. Okay? If the multiplicity is odd, the graph will cross the x-axis. Okay? So here's an example, right, where the multiplicities at each of these x-intercepts is odd. The graph crosses at each x-intercept. Okay. That's important information in graphing polynomial functions. Okay. Any questions on that? All right, so let's flip over to page 3. Sketch the given graphs. So in A, the polynomial function is not factored, and in B it is. So we have f of x in A, f of x is equal to x to the 4th minus 3x cubed plus 2x squared. Well, the first thing we got to do is factor the polynomial. Three terms. What's the smallest power of x? Smallest power of x is 2, right? So we can factor out an x squared. We have x squared times x squared minus 3x plus 2, right? Now this inside parentheses is a quadratic. Does that quadratic factor with whole numbers? Yes, it does. So we have f of x is equal to x squared times x minus 2 times x minus 1. So what are the zeros or the x-intercepts? Well, you said x squared equal to 0. You get x is equal to 0, right? What's this multiplicity? Well, let's do it. I'm going to actually create a little table. Okay? So we're going to create a table with the 0 or x-intercept. And then state its multiplicity. So when you say x squared equal to 0 and solve for x, you get x is equal to 0. And it has a multiplicity of 2, right? Then you set x minus 2 equal to 0 and solve for x, and you get x is equal to 2 with a multiplicity of 1, because the exponent on this factor, x minus 2, is the invisible 1. And then when you set x minus 1 equal to 0 and solve for x, you get x is equal to plus 1. And then it has a multiplicity of 1. And so now we can graph this polynomial function. Get a crude graph of it. Let me ask you one last question. What's the leading term of this polynomial function? What is it? X to the 4th, right? That's the largest power of x. That's the leading term. What's the end behavior? Both ends go up, right? Acts like a parabola that opens up. So x to the 4th, right, is the leading term. This polynomial. And so the graph goes up on the left end and it goes up on the right end. So now we know the x-intercepts, the multiplicity, those x-intercepts, and the end behavior. Okay. So let's see if we can get a crude graph. X-axis, y-axis. And so minus 1, plus 1, plus 2. And just for kicks and giggles, let's throw in the, we already have the y-intercept, right? The y-intercept. I didn't mean to put minus 1, I meant to put 0, right? 0, 1, and 2. So the graph goes up on both ends. I may erase that. But at x equals 0, the multiplicity is 2. So when the graph comes down, does it cross the x-axis or does it touch and churn? Touches and churns, right? So it's going to come down, touch at x equals 0. Now at x equals 1, is the graph going to cross or touch and churn? It's going to cross, right? So it's got to come down and touch at x equals 0. It's got to have a turning point somewhere between 0 and 1. And then come down and cross at x equals 1. What about at x equals 2? It's going to cross because the multiplicity is odd, right? So this is making a point, right? This multiplicity at x equals 0 is even, and these two guys are odd. It's not so much the number of the multiplicity, it's whether it's even or odd. And so the graph's going to have a turning point between 1 and 2, and then come up and cross at x equals 2. Okay? And so that's a crude approximation to the graph of this polynomial function. Okay? We got the end behavior and the behavior at each of the x-intercepts, which are also called zeros, right? Because the value of the function is 0, right, at the x-intercepts. Okay. Are you with me? All right. In B, the polynomial has been factored for us. We have f of x is equal to negative of x minus 4 cubed times x minus 3 times x plus 2 cubed times x plus 5 squared times x minus 1 squared. Okay? So, how many x-intercepts are there in the graph of this polynomial function? How many x-intercepts? 5, right? So 1, 2, 3, 4, 5 factors. Okay? So, at the top of your paper, right, in the space above here, right, you might want to put this table. I created a little table. Right? First column, I list the x-intercept, which is also called the 0 of the function. And then the second column, I listed the multiplicity for that x-intercept. Okay? So, to find the x-intercept of zeros, you set each of these factors equal to 0 and solve for x, right? So when you set x minus 4 cubed equal to 0 and solve for x, what do you get? You're going to get x equals 4. What's the multiplicity? It's the exponent on that factor. In this case, it's 3. Then I set this factor, x minus 3 equal to 0. I actually did this below the graph, so we can do it. X minus 4 cubed is equal to 0. And when you solve that equation for x, you get x is equal to 4. And when you set x minus 3 equal to 0, the factor x minus 3 equal to 0, you get x is equal to 3. And when you set the factor x plus 2 cubed equal to 0, you get x is equal to minus 2. Now with practice, you'll see, you'll just be able to plug in, right? You'll see you put in 4 in for x here, 4 minus 4 is 0. Put in 3 in for x here, 3 minus 3 is 0. Put in negative 2 in for x here, negative 2 plus 2 is 0, right? You don't necessarily have to write all this out. And then we have the factor x plus 5 squared is equal to 0. X is equal to negative 5. And then we have the factor x minus 1 squared is equal to 0. Means x is equal to 1. So the x-intercept, or 0, x equals 4, has a multiplicity of 3. The 0, x equals 3, has a multiplicity of 1, right? Because the exponent on x minus 3 up here is the invisible 1. Minus 2 has a multiplicity of 3. minus 5, x equals minus 5 has a multiplicity of 2, and x equals 1 has a multiplicity of 2. Okay? So these first three multiplicities are all odd, and the last two are even. Okay? So we know at these first three x-intercepts, the graph is going to cross the x-axis. And these last two x-intercepts, the graph is going to touch and turn. Okay? So now let's see if we can come up with a crude approximation to this graph. Okay? Now, we got one last little piece of information, the end behavior of this thing. Okay? So, the degree of our polynomial is found by adding up these exponents, adding up the multiplicities. 3 plus 1 plus 3 plus 2 plus 2 is equal to 11. So that is the degree of the polynomial, right? You add up the multiplicity or these exponents on the factors. Okay? So the degree of our polynomial, n, is equal to 11. And the leading coefficient, this minus sign out here is what number is this out here in front? -1. So the leading coefficient is -1. So if you have, remember the leading term of the polynomial is like a times x to the n. Well, a in this case is -1, and n is equal to 11. So the leading term for this polynomial function, if you expanded all this, take you a month, but if you expanded all this, the leading term would be minus x to 11. So what's the end behavior on this graph of this polynomial function?
Left goes up and right goes down.
Yep, exactly. The left end is going to go up, and the right end is going to go down. So now we got the end behavior, we got the x-intercepts, we got the behavior at the x-intercepts. And now we can do a crude graph. Now you could also find the y-intercept by putting in 0 and for x, and then doing all that arithmetic, but I didn't do it. Okay. I did see if it was positive or negative, but I didn't calculate it exactly. So here's our coordinate plane, x-axis, y-axis, okay? And so here's 1, 3, 4 on the x-axis, and -2, -5. The beauty of me drawing this on the board is I get to use all the space I want. Okay. All right, so we know the left end is going to go up, and the right end is going to go down. So what happens at the x-intercept -5? The multiplicity is even. So what's the graph going to do at -5? Touch and turn, right? So it's going to look something like that at -5. The multiplicity at x equals -2 is odd. So what's it going to do at x equals -2? It's going to cross, right? And so since it touch and turns here, there's got to be a turning point somewhere so that the graph crosses at x equals -2. X equals 1, the The multiplicity is even. So what's going to happen at x equals 1? What's the graph going to do? Touch and churn. So the graph's got to come down, turning point somewhere, come up and touch the x-axis at x equals 1. Touches and churns. What about at x equals 3? Multiplicity is odd, so the graph is going to cross. And then at x equals 4, the multiplicity is odd, the graph is going to cross again, right? So it's got to come down, churn, cross at x equals 3, churn, cross at x equals 4, and then go down forever. And that's our crude graph. Of this polynomial function. Yes, sir.
I'm sorry, I missed where you found leading coefficient. That's just the negative in front of the entire factored polynomial, right? For leading coefficient is -1.
Yeah, because there's a minus sign here. You see the minus sign?
Yeah.
That's right. That's actually -1.
Okay.
Yeah. We always have the invisible 1, right? So the leading coefficient, right, is -1. Good question. Any other questions? Okay, let's take a look at example 5 and then we'll take our quiz, okay? I find this to be lighter fare than what we were doing yesterday. Finding the derivative, square roots. All right, the cubic polynomial, p of x, has a 0 of multiplicity 1 at x equals 1, a 0 of multiplicity 2 at x equals 2, and the value of the polynomial function at x equals -1 is equal to 2. Determine p of x and sketch the graph. Okay? So, x equals 1 is an x-intercept. So, subtract 1 from both sides, and you get x minus 1 is equal to 0, so x minus 1 must be a factor in the polynomial function. And it has a multiplicity of 1, right? So it's x minus 1 to the first power is equal to 0. Then there's a 0 of multiplicity 2 at x equals 2. So we have x is equal to 2. So x minus, we subtract 2 from both sides, you get x minus 2 is a factor in the polynomial. But it has a multiplicity of 2. So that means x minus 2 squared is a factor in the polynomial. Okay. And then we're given the additional piece of information that polynomial x equals -1 is equal to 2. So we can write the polynomial function p of x as the leading coefficient a, we don't know what its value is yet, times these two factors, x minus 1 times x minus 2 squared. Right? So you can see our polynomial has a 0 or an x-intercept at x equals 1, and it has an x-intercept at x equals 2. The 0 at x equals 1 has a multiplicity of 1. And the 0 at x equals 2 has a multiplicity of 2. And then we have the unknown leading coefficient. Okay? Well, we're given that the value of the polynomial at x equals -1 is equal to 2. So I put in -1 in for x on the left and right hand side. I have a times -1 minus 1 times -1 minus 2 squared. Well, what's p of -1 equal to? it's equal to 2. So I replace P of minus 1 with 2. And I'm going to solve for A. Minus 1 times minus 1 is minus 2. And minus 1 minus 2 is negative 3. And negative 3 squared is 9. So I'm just solving for A. Once I know A, I have polynomial, right? So minus 2 times 9 is negative 18. So minus 18A is equal to 2. I switched the two sides. And then when I divide both sides by negative 18, I get A is equal to minus 1/9. So P of X is equal to minus 1/9, right? That's what A is, times X minus 1 times X minus 2 squared. This polynomial function meets all the conditions in this example. Okay? So this is our factored polynomial. Okay? What's the degree of our polynomial? Yeah. You add the exponents, right? The multiplicities. Degree is equal to 3. What's the leading coefficient? Yeah, it's minus 1/9, right? So the degree is odd, the leading coefficient is negative. What's the end behavior? Up on the left end, down on the right end, right? So here's what, we'll graph this thing first thing tomorrow. Let's see if you can come up with the graph, okay? Before class tomorrow, okay? I don't think you need the whole 10 minutes for the quiz, but I'm gonna give you the time.